Good morning to lecture, and today I'm going to take a short video about experiment 3B, which is projectile motion. Okay, I will do for the objective 1, which is determine the range of horizontal displacement as the function of the projectile angle. And my group mate will do for the objective 2 and 3. Okay, for my objective, we want to determine how the projection angle change will influence the range of horizontal displacement. We have to see by this simulation. Okay. For my objective, I said I use the cannonball for the projection object, and this one, the mass I set at 50 kilogram. The diameter is 0.2 meter. Gravity is 9.81 meter per second square. Okay, the initial speed I set for my objective, the initial speed is constant. We just need to variable the angle and see what is the range of horizontal displacement. So this one I set at 50 meter per second. The last start, I will do from start from 30 until 90. Okay. So start. Okay. 19.6, 22 until 45. Twenty two nine four. 22 for 60. Set 19.86. Then 2 for the 75 degree. Okay. 11.47. Then test for the 90 degree. 90 degree, there is no rank is 0. Rank is 0. Okay, from here we can look at the ranks for the horizontal ranks for the 45 degree. This one is like 45 degree is the maximum. For this one, I will explain at the discussion of the report later. Okay, thank you very much.
The second objective of this experiment is to determine the maximum height of the projection. So firstly, we set the initial speed of the cannonball to 15 meter per second. The mass is 15 kg, the diameter is 0.2 meter, and the gravity is 9.81 meter per second squared. So the first inclination angle is 30 degrees, and then we launch it, and then we use this tool to determine the maximum height, which is 2.87, and then the second inclination is 45. We launch it. The maximum height is 5.73 and followed by 60 degrees. The maximum height is 8.6 meter, and then 75 degrees. The maximum height is 10.7 meter, and then finally 90 degrees. The maximum height is 11.47 meter. This is how the maximum height is obtained through this simulation process.
For the third objective of this lab is to determine the maximum range of horizontal displacement as a function of initial velocity. First, we set the initial speed for the for this objective is 5 meter per second, and we launch it. And then we drag this to get the maximum range of displacement is 2.21 meter, and followed by the 10 meter per second, and then launch it. We get the maximum range of displacement is 8.83 meter, and then followed by 15 meter per second and launch it. We get the maximum range of displacement is 90.86 meter, and then followed by 20 meter per second and launch it. We get the maximum range of displacement is 35.31 meter, and then followed by 25 meter per second and launch it. We get the maximum range of displacement is 55.70 meter, and then last 30 meter per second and launch it. We get the maximum range of displacement is 79.45 meter per meter. That's all to get the maximum of range displacement. Thank you.